Hi everyone, so today we're in the dome again. One of the issues I've got with the dome is the Wi-Fi connection. It's about 20-25 meters back to the house, and the Wi-Fi has never been the best, and even the position of the laptop lid, if it's open or closed or where somewhere in between, can have a big effect on the Wi-Fi. And once I start adding in things like the additional monitoring with the cameras, I've also got a camera on the back of the RASA that looks out the dome, or looks along the length of the telescope, so I can see that everything's okay with the dome positioning. And I've also got, for the rig outside, I've got another camera that also looks at that. So when you start adding all these monitoring, it consumes what little bandwidth there is back to the house, and has an effect on the quality of the signal. So one of the things I tried to do was I put another extender in the window of the house, or one of the windows up in the upper hall, and that did help to some extent. However, with the design of the house and the positioning and the sockets and where I can get power points and things for Wi-Fi extenders, the orientation and the concrete walls and the diagonals and all these sorts of things, it has a big impact on the overall quality, particularly when I'm trying to operate remotely from in my home office. The latency signals significantly increase, the signal quality is intermittent, and I get a lot of lockups, particularly when remote monitoring. So what we're going to do now is we're going to try and fix all that. Bought some new Wi-Fi equipment, and what I'm planning on doing is installing a new Wi-Fi access point in the dome. And then I've also got a couple of Wi-Fi adapters which are designed as point-to-point bridges. And then I'm also going to put another Wi-Fi access point and router inside the home office, which should also help with the quality of the Wi-Fi up in the house upstairs. And then from that router inside, I'll put a hardwire back through to the main Wi-Fi router, which connects out to the dish supplied Wi-Fi. So we're going to have a look at that today and see how we got on there and what improvements it gives me. So let's head over inside and see what the next stage is. Alright, so one of the first things I did was go around the house in all the rooms where there was TV points and telephone access points, and I took all the covers off of all these points, and I took a note, started to build a map of what cables were coming out, whether they were TV coax, satellite coax, whether they were phone cables, alarm cables, all these sorts of things, and started to take a note of what they were, what colours they were, if they were thick, or thin, and also in all the boxes themselves, they have a 20mm box, 20mm conduit, 25mm, 30mm, and that helps to try and narrow down some of the routings. And then the next thing I did was try to actually prove where all the routes go, because some of the cables and things loop through other boxes and they aren't straightforward point to point. And obviously, not being a property that I have built or previously worked in, this is just the rental one that we've got here in Cyprus. I don't have drawings for how they've designed the building. So to try and prove all the different routings and which conduits are empty and where did they go, starting with the points where I was trying to get cables through as part of the upgrade. The first thing I did was to use my trusty old iPod and playing some music, and then stuffing the earbud down inside the conduit and then walking around all the various points trying to hear where the music comes out. That helps to try and identify which cables are which. And also the other option, of course, is to, with some of the cables, you start to gently pull on them and see if you get movement at each end. Obviously you don't want to move it too far, but there's always a danger with that if the cable is caught because of movement within the building, the cable can actually be snagged, and you could end up damaging the cable, which we clearly don't want to do.
And other than that, we also use a fish. So here I've got a nylon electrical fish that I can stuff down the conduits, and whether they're the empty conduits or conduits with cables already in place, and also try to hear as it moves around the rooms and through the walls and things where it's going, and try and use that to identify. And then also I can use this for pulling in cables when I get to that stage. The other methods that we can use for trying to identify where the conduits go is you can use a vacuum cleaner. You can try and get a good seal around the top of the conduits and try and pull the air through and walk around at the other end and see when you put your finger over the end if you're pulling a vacuum. And then the other option, of course, is if you've got one of these small electrical pumps for inflating like swimming pool lilos and things like that. You can stuff that into the top, blast air through it, or try and pull a vacuum using those. Also, it's quite noisy, so that helps for the longer runs. But my preferred go-to route is the iPod, and then the electrical fish. However, you've got to be careful. Obviously, if you don't know where the conduits are going, you don't want to be stuffing something with a metal end into a box that could potentially come into contact with something that's live. And that's why I tend to try and keep away from any boxes that look like they could be related to the power sockets and things like that. But fortunately there's enough separation in the property that it looks like all the power related ones go back to the main distribution boards. There's one on each floor. There's one in the pool room as well. So once we've done that, I ought to try and then work out, again using my map, how I can get a cable from the loft to my office, which is going to pick up the Wi-Fi bridge, and then from the router, which is going to be in my office, I need to get a cable down to the main Wi-Fi point via some convoluted route through all the ductings. Now fortunately I found that there is 4 network cables that's been spread around the house for various things by previous occupants, and I can make use of 2 of those. So hopefully the cables are in good condition once I run a cable tester through them, and that'll prevent me having to try and rerun any new cables through those. But I've already managed to find cable ducting that comes down from the loft, and I've pulled in some of that cable already. And I've also managed to find from here, this box in here, which is in the back of a wardrobe in my daughter's bedroom, I managed to find a route through into my office, and also pulled in another couple of Ethernet cables to get back to where I'm planning on putting the router in my office. So far so good with the cabling side of things, so let's go and take a look at the hardware I'm planning installing next. Alright, so here we are in my office. This is where I do all the remote observing from, and this is where I'm planning on installing the router. So in my box of goodies that I've been buying, I've decided to go with the MikroTik brand. This is one that's easily available here in Cyprus, and all the equipment that I've bought for this is all MikroTik. And obviously if I buy it locally and there's any issues, then it's easier to deal with returns and warranty and things like that. So first thing I've bought is a RB4011 router and an access point. So this is going to go inside the observatory, and this will give me, sorry, this one's going in here in the office here, and this will go in my office here, and we'll have a connection out to the bridge connections, and then I'll have the connections back to the main Wi-Fi router in the house. And then I'll also have my computer connected in here, my laptop and things like that can all hook up to this, and this will hopefully also improve the general Wi-Fi quality for the bedrooms up here on the top floor. because one of the issues we do have is with the concrete walls, the angles that the signals are trying to get through. The kids next door struggle in their bedrooms to get a decent Wi-Fi signal unless their doors are open and things like that. So hopefully this will try and alleviate some of those problems. The next thing is the router for the observatory. So this is MikroTik HAP series access point and router. So it's a 5-port and it's got 2 Wi-Fi antennas that will go onto here, and then I'll mount this somewhere in the observatory, and then one of these connections will go out to the bridge at the far end, and then I can use the LAN ports on here if there is any equipment I end up sticking in the observatory that requires a direct connection. I know one of the monitoring cameras I've got, it supports Ethernet connection, so I'll maybe use that for it and take a bit of heat off the Wi-Fi at that point. So that's going to go into the observatory. And then finally, again, MikroTik. So this is their wireless cube. This is a pair of cubes. So this will provide the point-to-point bridge connection between the observatory and the house. It comes as a pre-configured kit. So in the box we've got 2 cubes. Now these cubes are, this is one of them, and they're actually written on it, there's a master and a slave cube. So the master will go up at the house, and Ethernet, power over Ethernet connection. So I do have on both the router and the access point for the dome, there is a power over Ethernet port that's on the output side, so I can use them hopefully if they're the right voltage ratings to supply the power to the cubes. Failing that, the cubes are provided with PoE injectors which I can use, and there's also some mounting hardware. I haven't yet decided exactly where I'm going to stick it on the house, but that is one of the cubes, and basically the other box is exactly the same. So we'll just line these up, point them together. The distance is good for approximately 800 meters with these, and they work over a 60 gigahertz primary frequency, and in the event of bad weather and things like that, the connection can degrade quite heavily on a 60 gig network, so it has got 5 gigahertz fallback should that happen. But at the end of the day, if the weather's bad, I ain't going to be imaging, so it doesn't really matter. So these are the cubes, and these are the routers, so hopefully all going well. Let's get all this set up.
Alright, so we got all the cabling set up, installed, and I've tested it using a network tester, and everything's looking okay. I did have a problem with a couple of the jacks. I kept losing one of the cores on one of the cables, and this was down to the jack kept severing the cable inside its insulation at the punch block. So after changing those jacks out, everything was good again. So now I've got the hardware all set up here in my office. It's obviously easier to try and set everything up at a desk rather than having to run back and forth between locations and things like that. So I just set up everything on the desk with the new access point and router for the office, and I've got the bridge connection, the cube that goes in the house, the cube that goes at the observatory, and then I've got the access point router which goes at the observatory. So I've got them set up on here. Now I did get it all set up, everything with its default settings, all worked perfectly, and then unfortunately I managed to completely crap the setup. I was trying to change SSIDs, I was trying to change some security passwords and all these sorts of things, and I ended up actually managing to completely lose one of the cubes, and no matter what I did I could not connect to it. But fortunately the MikroTiks have got a mode in them that allows you to do bootx, which is effectively booting off the network. So I managed to get the cube into this special boot mode, and then using the MikroTik net install software, I managed to push, using a direct cable connection from my computer onto the device, I managed to push up all the default latest firmware back into the machine, and then rebuilt the configuration for that unit being a slave, and it's all now up and working. And when I've connected the laptop to the access point and the tablet to the access points and tried different access points, I've also got the computer now routed back through the office access point as it will be, and then this white cable is going back to the existing house Wi-Fi router. So everything is working good, fortunately, and certainly up here already in the office, putting the connection over a wired connection has significantly improved things on the computer itself, and then also connecting to the devices using the tablets and things, and then walking around the bedrooms. There's a significantly improved access on Wi-Fi from all the locations. So I'll just need to do a bit of fine tuning exactly where in the office I'll put it. It'll probably end up being sat on top of the computer, or I might stick it on the wall somewhere in a convenient position. But so far so good. So I've actually got the system set up at the moment doing a bandwidth test. So you can configure using the tools in the software for these routers. You can do an end-to-end bandwidth test across the link. So that's currently running via the computer at the moment. So let's hop over there and take a look at the throughput. Okay, so you probably won't be able to see any of the numbers or anything, but depends how good the quality is of the video and to YouTube. But what I've done here is I've opened up 4 Winbox terminals into each of the devices. So on the top left here we've got the new access point and router that's going in the office. In the top right I've got the access point that's going into the observatory. And then at the bottom here I've got the 2 cubes, which is the point-to-point network. So effectively the network's going to do that. And in the access point for the office I've opened up the bandwidth test tool, and it's pointing now at the observatory access point. We've got it set up to do a bidirectional test, and at the moment it's running around about 600 megabits transmit and receiving around about 400 megabits per second. So we're getting a really good connection there, probably saturated out now, the 1 gigabit network connection on the port for the device. Although the actual point-to-point bridges They've got a total bandwidth capability of 2 gigabits per second, which is obviously 1 gigabit in each direction to give you the 2 gigabits. And if we look at the torch that's running on the one of the cubes, we can see with that connection fully saturated, we are indeed getting around about 1 gigabit through that one connection across the network there, which is working really good. So hopefully once I get the points lined up, at the moment they're just obviously roughly pointing each other on the desk over on the test setup. So once I get them out and mounted, once the weather breaks, we've got heavy rain at the moment, which is obviously hindering any outside related work, but we'll get that set up and we'll come back to that when I'm ready. So we'll speak to you again soon. Okay, so after getting a break in the weather and doing all the hardware install outside, I've got everything up and running again. The line of sight point-to-point bridge didn't do any alignment on it other than just a straightforward visual, so just looking roughly where they were pointing at each other and then tightening them down. So we're back inside now, and I've done some testing and things are looking promising. So as you can see on the screen here, I've got the 4 WIN boxes open. So same as before, where the top left is the new access point and router in the office, which is hardwired back to the existing router for the house incoming Wi-Fi and internet. And on the right hand, top right hand side, we've got the access point in the observatory. And then the bottom 2, the one on the left, is the point-to-point wireless bridge cube running on the villa, and the one on the bottom right is the cube that's running on the observatory dome. So if I kick off a test, here I am in the top left, and I've got the bandwidth test tool configured to do bidirectional, and it's connected to the it's connected to the observatory access point. And if I kick off a test there, we can see the transmit and receive is coming in at 960 floating around 960, 970 megabits per second send, and it's receiving at 660 floating around there megabits receive. And you can see that at the far end in the observatory. So here I've got the bridge interface, which is all the Wi-Fi connections, the Ethernet port, and all the fallover management for the cubes for when it switches between the 60 gigahertz and the 5 gigahertz Wi-Fi should there be a problem. And there again we can see it's transmitting at 590 and receiving at 970 megabits per second. So we've got a real healthy link now between the house and the villa. So that is absolutely excellent. So if I switch over to the observatory, I've got remote connections dialed in to both the observatories laptops. So Obo Laptop 1 is the one that's used to run the RASA inside the observatory, and Obo Laptop 2, that's the one I use for the outside rig, which is currently the Edge 11 setup out there. And the Obo Laptop 2, so the one for outside, I've still got it set up to use the existing old Wi-Fi link that I had, Obo X2G it's called. It's a 2 gigahertz Wi-Fi extender, and Obo Laptop 1, that's connected to the new setup through the Obo 5G link inside the observatory. And everything feels a lot snappier, no problems there. Opening up Chrome, opening up YouTube, you can see that everything comes in a lot fresher on the new link. And we're opening up Nina, you can see we've got no problems there as well. So everything is absolutely working great now. So I just need to now get all the other hardware connected across to the new access point. So that's all the monitoring cameras. I'll get set up on there. I do have one or two minor problems I've still got to resolve. There's a couple of the Ethernet jacks in the house seem to be a bit temperamental with the connection. I think they're just poor quality jacks, so you wiggle the plug on them and you lose the connection, so they're sort of forced in place at the moment. So I'll get them replaced at some point, but the link is staying healthy at the moment. And then I've just got some minor cable routing and tidy up to do in the boxes, just to box everything up finally and walk away from it. So at the end of that project, I think I'm very pleased with how it's gone. Yes, there was a few issues with some of the hardware and some of the configuring, but a few days of tinkering during the rain, it's given me something to do, and the outcome has been very positive. So hopefully now I can get better quality streaming, live streaming, better quality image transfers, and particularly with the remote desktop operation now, I'll be able to set up automatic copying of all the images as they come in across to the inside for processing, and I'll maybe even drop a couple of remote disks into the observatory there just to do backups. And then hopefully down the road I'll be able to set up some cloud transfer, so that if I do try to operate the rig remotely, I'll be able to pull off the images off the cloud and everything. So that brings to the end this project of the Wi-Fi upgrade to the observatory. So thanks for watching, and look forward to any comments and feedback or any questions you've got. And if you like this video, give it a thumbs up, and I do appreciate if you subscribe to any content now associated with the Astrophotography channel, any imaging sessions, live streams and things. I'm sure there'll be lots to come once the weather improves. So on that note, thanks very much, clear skies, and we'll see you in the next one. Bye for now.